Okay, we've looked at parabolas before, but today we're going to look at parabolas from a slightly different perspective, the conic section perspective. By the way, conic section, the root word of conic is cone. So if you take two cones, put them tip to tip, like we have here, if you have a plane cut horizontally through, you would get a circle, and that ties into what we did yesterday. If you have it cut at a little bit of a diagonal, you get an ellipse, which is just an elongated circle. If you have it cut so that it's parallel to one of the edges here, then you get a parabola. If you have it cut so it's more straight up and down, then you get what's referred to as a hyperbola. It's almost two parabolic shapes going in opposite directions. But we're going to focus more on the parabola here. Now, the definition of a parabola from conic perspective is a set of all points that are equidistant from a given point, called your focus, and a given line, called your directrix. So over here on your diagram, your given line is your directrix, and your given point here is your focus. And a parabola is a set of all points that are the same distance away, while your vertex is exactly halfway in between. Or this point right here, it's just 2 units to the right and also straight 2 units up. Same with this one here. It's 2 units left and straight 2 units up. Now, if we look here, if we go from this point up to this point here, that's going up 5. If you did your distance formula to go from this point to your focus, that would also be 5 because it's Pythagorean theorem 3, 4, 5 right triangle. So if you would plot all those points that are the same distance away from the red focus in the given line, you get this purple parabola, hence the purple parabola here. Now, we also have our vertex, which you guys are familiar with. We've dealt with that before. We also have your axis of symmetry that cuts it in half so each side's their mirror image. We've dealt with that before. We also have a special chord. A chord goes from one side to the other side in a circle. We also have a chord that goes from one side to the other side in a parabola. So it's a special segment that goes from one side to the other side. It has to go through the focus, and it has to form a right angle being perpendicular to your axis of symmetry. The length of that is just 1 over a, where once again a is what's in front of your squared term. Now, the distance to go from your vertex to your focus, or your vertex to your directrix, is also given to us in a formula of 1 over 4a, and it's distance, so it's going to always be positive, hence the absolute value. Same idea here with our absolute value. So that was my diagram I used. So looking at this one, we want to go ahead and look at this and find all this information. Now, if you are opening sideways, then you're in this red form in the middle of the screen. So if you're opening sideways, it's going to be in one of these two forms. As a side note, if we go back here, and if you're opening up or down, you would be in this form here. This is the form that you're used to seeing in the past. So if it's y equals, it opens up and down in the y direction. If it's x equals like we have here, it opens in the y direction. Now, h and k is your center. Notice when you switch to the x equals, the h and the k switch spots. So just be aware of that. So to go ahead and complete the square on this, we want to complete the square at the y's because the y has a squared. I'm going to get my y's on the same side. Then I'm going to go ahead and group my y's together. So I'll lay the -1 out. Now, when you're completing the square, remember what's in front of your squared term has to be positive, so I'm going to pull a -1 out of the y's. Now I'll complete my square. Remember, in completing the square, you got to take half of what's in front of your y to the first. Half of that's 2, and then that's squared. That's what you add. Now, if I add it on the right side, I now have to subtract it on the right side. But keep in mind that what we have in front of this red -1 affects what we did here. So when we are offsetting it, subtracting it, we have to do that what's in front of -1 times what we added. Now remember, what's in your parentheses here factors into two identical parentheses. What's being squared here, what's being squared here, and you take your first sign. Since it's two identical parentheses, you could write it as one parenthesis all squared. Here you get 4, negative, negative, so you'd be adding 4, and then we get this. Now, when you're opening sideways, h is always your x-coordinate, is what's on the outside. K is your y-coordinate, and it's when you're in the parentheses, it's always the opposite of that. So it's be the opposite of that. Now, we know we're opening in the x direction, so that's left or right. But because it's negative, we know we're opening to the left. So you see the parabola up there, but if I were you and I was doing this and you didn't have that, I would go ahead and plot the vertex. And then I would just do a rough sketch opening to the left, kind of like this. If you have a nice rough sketch, doesn't necessarily have to be accurate, but if it did say graph and it wanted it to be accurate, then you should be able to do that. And I guess it does say graph. Now keep in mind, you can use that pattern of 1, 3, 5, 7. So we go up 1 over 1, up 1 over 3, up 1 over 5. You could use that pattern. Also, you could make yourself a t-chart. Now normally we have plug stuff in for x to figure out y, but because we have x equals, we can plug stuff in for y to work it out for x. So you could do that if you wanted to be able to plot your points. Now, with the visual, you can see your axis of symmetry would be a horizontal line. It's going to go through your vertex, which is at a height of 2, so you know it would be y is equal to 2. Now, to figure out for your focus here in orange, and your focus is always in the direction of your opening, which is left, so we got to be to the left of our vertex. Your directrix is always in the other direction, so that's going to be to the right. That 1 over 4a tells you how far to go from your vertex to your focus or vertex to your directrix. In this case, a is -1. We plug in -1, we get 1 over -4, but remember we're dealing with distance, so it's 1/4. So we have to go 1/4 of a unit to the left. Well, we were at 3, we go 1/4 of a unit to the left, then that's going to tell us our focus. We're not changing our height. We were at 3, go 1/4 of the unit to the left, and that would be at 11/4, or 2 3/4, comma, 2. Focus is a point. Your directrix is a line. So to get to our directrix, we then have to go from our vertex 1/4 of a unit to the right. Your directrix and axis of symmetry are always perpendicular. So if we were at 3, go 1/4 of a unit to the right, that'd be 3 plus 1/4, so it'd be 3 1/4. Or you could try to write it as an improper fraction. And then remember, it's a vertical line, so it's going to be x equals, so we get x is equal to 13/4. Looking at the length of your latus rectum, that would be the length of this chord going straight up and down perpendicular to your axis of symmetry through your focus. That formula is 1 over a, plug in -1, it'd be 1 over -1, absolute value of that is 1. So that's what we would do for a problem like this. Now, this one, we're only asked to go from the normal form into your vertex form. So we'll go ahead and complete the square. So to complete the square, I need to go ahead and get the y's on the same side. So I'll add a y squared to both sides. Now, the 4 in front, I don't want there. Excuse me, because I want x on one side all by itself. So I'll multiply everything by 1/4 or divide by 4, doesn't make a difference. Now remember, in completing the square, what's in front of my y's, I want to be 1. So I'm going to take a 1/4 out of the y's. I'm not taking it out of that normal number because I'm not completing the square with that normal number, so that stays here. Now I'll complete the square. So remember, I got to take half of b, half of 2 is 1. So if I add it here, I then have to subtract it here. Now keep in mind, this blue 1 is in parentheses being multiplied by the red 1/4. So I added a 1/4 times a 1. So now I got to subtract a 1/4 times a 1. What's in your parentheses factors into two identical parentheses, so you could write it as 1 parenthesis all squared. Back here, you'd be subtracting 1/4 from this, so that would give you 12/4, which is just 3. This one is already given to you in vertex form. You need to go ahead and find your vertex and all that stuff. Now your vertex, because it's y equals, we know we're opening up or down. Because it's positive in front, we know we're opening up. Your vertex then is hk. It's always the opposite of what's in the parentheses, same as what's on the outside. Now that I have that, I would do a rough sketch. I would plot my vertex over 1, down 5. And then I would do a rough sketch of my parabola. So let's see here. I know I'm opening up, so I'll go like this. Now with that in mind, oh, that's kind of ugly. Now with that in mind, you can see that your axis of symmetry would have to be going up and down to cut your parabola in half. So we could draw that in. And wow, that's kind of small, but I think you get the idea. That would then be x is equal to 1 because that's the x coordinate of your vertex. So to find your focus in your directrix, remember your focus is always in the direction of the opening. We're opening up, so you got to go 1/4 of, or 1 unit up, or however many, 1/4a units up. We know a is 2, so if we plug in 2 here, because a is what's in front of your squared, 1 over, then it would be 1/8. So we have to go 1/8 of a unit up to get to your focus. So I'll plot my focus, and that would be about here. So focus is a point. So if I'm going straight up and down, I'm not affecting my x. And I was at -5, I have to go up that 1/8. So if I take -1/8 with a -1/5 and add 1/8, I get this. My directrix then would be then 1/4 of a, or 1/8 of a unit down, and it would be a horizontal line. So if I was at a height of 5, went down 1, that would then be subtracting. I know I'm horizontal, so I know it's y equals -5 minus 1/8, and I get this. And then latus rectum would be 1 over a is 2, so it gets 1/2. Now, if you want more of an accurate graph, it would be more like this. But I would do it just like I did here, rough sketch. Now, when you're graphing this, you could use that pattern of 1, 3, 5, and so on, but you'd have to multiply it by the number in front, or you could make yourself a T-chart, would not make a difference.